Good day, grade 11s. Today we are looking at the inclination of a line, and this is part of the analytical geometry chapter in your textbook. And let's just take a few basic concepts and talk through it. I think you will enjoy it. It's a nice and easy chapter, easy to understand, and quite enjoyable. Okay, so let's start off with our Cartesian plane, and then from there on, I'm just drawing a straight line. And then I'm indicating that the angle made with the horizontal is theta, just for reference, so keep that in mind. But first of all, I want to refresh your memory regarding the gradient of a graph, a straight line graph. Now we know that the gradient is the difference in y coordinates divided by the difference in x coordinates. Okay, so if we write this, we expand this, this will be y2 minus y1 divided by x2 minus x1. So if we look at this and just have a look at our graph, I'm going to indicate 2 points. Okay, so let's call that point number 1. And the one there at the top, we're going to call point number 2. Okay, so point number 1 will have x1 and y1 as its coordinates. And point number 2, x2, y2. So the difference in the y coordinates, y2 minus y1, will look like this. Let me just draw a little triangle. Keep in mind that these lines, this one is horizontal and this one is vertical. Okay, so if we talk about the y coordinates, y2 is over there and y1 is over here. Right, so this distance is y2 minus y1. And similarly, right here, this will be x2 minus x1. Okay, so keeping that in mind, we know we can calculate the gradient. But I want you to understand the following, that if theta is the angle made with the horizontal, the x-axis, that means this angle right over here will also be theta because we have parallel lines. So looking at this triangle right over here, I want you to express theta in terms of sine, cos, or tan, based on the information we have gathered. And if you look at that, you will notice that first of all, tan theta is opposite over adjacent. And I want to write it down just first. So tan theta is equal to opposite over adjacent. Okay, now let's look at this triangle. Which side is opposite theta? It will be y2 minus y1. And which side is adjacent to theta? Well, x2 minus x1. And you will see that these are the same. y2 minus y1 over x2 minus x1, y2 minus y1, x2 minus x1. Then, based on this, we can conclude that tan theta is equal to n. This angle, this theta, we call that the inclination. And that's how we can calculate the gradient. So if we have this angle right over here, or that one, we can calculate the gradient of this triangle. You can go and test it. An easy one would be tan 45. We know that tan 45, these two sides will be adjacent. The adjacent and the opposite side will be equal in size because of the 45-degree angle. And if that is the case, we know the gradient should be 1. But now just go and test it, say tan 45 equals, and you will get an answer of 1. Now it's easy to explain and to understand with a graph having a positive gradient like this one. Just to recap, a horizontal line has a gradient of 0. The line looking like this one has a positive inclination, that means it is a positive gradient. A vertical line does not have a gradient, but it is undefined. And then a line looking like this will have a negative gradient. So, if we look at this graph right over here, this line will have a negative gradient. Now, our inclination is right over there, angle of inclination, theta. Now, if you take your calculator, for instance, let's say we know that the gradient of this line is equal to -1. If you take your calculator, you say second function tan -1 equals, you will get an answer of -45. But we know that doesn't make sense, right? -45, how does that work? Okay. But if you remember your cast diagram, you will remember that tan is positive in the first quadrant, but negative in the second quadrant. And if you use the knowledge that you've gained with that chapter and say, okay, I know it's negative, therefore it's in the second quadrant, and I'm going to use my reference value of 1, you will get 45, right? You will just get 45. So that means you'll get this angle right over there. Because in the second quadrant, we are looking at 180 minus theta, right? So technically, this is its position. So this angle size, theta, will be 180 minus 45. Let me just call that something else, okay? So this will be 180 minus 45. So if we need to get to this value, it's very easy. You just say second function tan of -1, you'll get a -45. Knowing that this is a straight line, you can literally just say plus 180 and you'll get this value of 135. So that's a quick and easy way to calculate it, but in understanding it, this is what's taking place. We are working the second quadrant, so we have an obtuse angle, and that's why it works. But again, a quick calculation, you just need to calculate it. You just say second function tan of -1 or whatever the gradient is when it's negative, and you'll get a negative answer, and that is your clue. If you get a negative answer, you add 180 and then it will give you the inclination. If it's a positive one, you will just immediately get a theta, the correct answer.